Welcome to Brain Vision.
So the problem 59 deals with different definitions of concentration for a given solution. And first, let's write down what we know. We're given an aqueous solution of glucose with the mass of glucose being 28.4 grams. Then we're given the mass of solvent, which is water, equal to 355 grams. We also know that the total volume of solution is 378 milliliters. Okay, and we're given a task of calculating molarity, weight percentage, mole fraction, and mole percentage. So let's go point by point, starting with a molarity. So we know that molarity is defined as the amount of solute divided by volume of solution. We already see that we are missing amount of solute, but we can calculate that from mass and molar mass of glucose by saying amount of solute equal to mass divided by molar mass. So in this case, it will be 28.4 grams divided by 180.16, which is the molar mass of glucose, grams per mole. Okay, and this results in 0.158 mole amount of solute. Okay, so we have volume of solution, we have our amount of solute, we can calculate the molarity from that by saying 0.158 moles divided by, so we're given a solution in milliliters, but the concentration is usually has the units of mole per liter, so I will recalculate the milliliters into 0.378 liters and put it in here, 0.378 liters, which gives me the molarity of 0.417 molar, or mole per liter, however you like. Okay, so this is A. Let's move on to B, molality, which is defined as amount of solute, which we already calculated, divided by mass of solvent in kilograms, which is very important. It's not the mass of the total solution, it's the mass of solvent, which is in our case given it's water 355 grams. So we can just put it straight into the equation, 0.158 mole divided by in kilograms. So let's convert that to kilograms, 0.355 kilograms. Okay, 0.355 kilograms, which gives us a molality of 0.445 little m. Okay, now we can go to C, which is weight percentage, which I will just mark with weight percentage. WT percent. It's defined as mass of solute divided by mass of solution, not the solvent, and multiplied by 100%. So in this case, we have everything we need to calculate it. So we're gonna just put our mass of glucose in here, 28.4 gram divided by 383.4. 4 grams times 100%, which should give us the percentage of 7.41% by mass. Okay, so this is C. Let's move on to the next concentration. Next, we need to calculate a mole fraction, and it's defined as amount of solute divided by amount of solution, which in our case, we don't know the amount of solution yet. So what we need to do here is calculate the total amount of, it's D. What we need to calculate is the total molar amount of the solution. How do we do that? We actually just add amount of solute to amount of solution. So this equation can be rewritten as follows: amount of solvent plus solute. This means we need to calculate the amount of our solvent from the mass that we're given, which is easily done. Amount is, as we know, mass divided by molar mass, which is for water 19.01 grams per mole. I'm not going to go into detail about it. You can look up the equation. So the amount of solvent from that equation would be 19.7 moles. So now we can recalculate this by putting in our amount of solute, 0.158 again, divided by the thing that we just calculated, 19.7 moles for water, 19.7 plus 0.58, and this of course both in mole. Okay, and when we put these values in our equation, we get something like 7.15 times 10 to the power of -3. And this is our mole fraction. And the last thing we need to calculate is the mole percentage. I'm going to just call it this. And it's defined as amount of the solute divided by amount of solution, just represented in percentage. So you can imagine that it's just a mole fraction times 100%. So that's easy. Let's simplify it like this. And when we multiply the value that we calculated here, which has no units because it's a fraction, we get 0.795 percentage by mole. Okay, so we calculated all of the values and yeah, defined all of the concentrations.